My name is Allie Crisatello. I just finished my third year in the MIT Woods Hole Joint Program, and I'm in the Geology and Geophysics department, and I study glaciology. I originally became interested sort of not through academics. I was a climbing ranger in the Park Service in Washington, and I lived and worked on ice, and I loved it. And then when I was finishing my undergraduate degree, I kind of decided to see what it would be like to study ice. I grew up outside Boston in Winchester, Mass, and I did my undergraduate degree at Wesleyan University in Connecticut, and then I did my master's at Lamont in New York. So the basic idea is that in the austral summer, every year sea ice breaks up, generally, and when the sea ice breaks up, it's the first time that the upper water column has seen light. So there's a big phytoplankton bloom, consists mostly of sea ice algae around Antarctica. And these phytoplankton give off something called DMSP, and it goes through a bunch of different chemical steps, but it is converted to DMS, or dimethyl sulfide, in the ocean. And then that's exchanged with the atmosphere, and it's oxidized in the atmosphere to methanosulfonic acid, or MSA. And if you've got winds that are bringing this signal over the ice sheet, the MSA will be deposited as snow on the ice sheet. So there's this relationship between the sea ice breakup and the phytoplankton bloom and the concentrations of MSA that are recorded in the coastal ice sheet. So sea ice is very important in the ice-ocean atmosphere climate system, and it's sort of one of the big things we don't have any sort of record of before the satellite era. So the idea with this kind of work is to validate this proxy, or this new measurement of sea ice extent over the satellite era, where we actually have real reconstructions of sea ice concentration. And if it looks good, then we can use this chemical marker pre-satellite era. I do a lot of field work. I just finished my 4th season in Antarctica, and I work in a small team, about 5 people or less, in the deep field. So we don't work out of one of the U.S. stations. We get dropped off by a little fixed-wing plane in the middle of the ice sheet and set up tents and set up a drill and drill. And we use 2 different drills. One goes about 10 meters, and it's a hand auger, so there's no mechanized part of it. And then we also use the U.S. Eclipse drill, which can go a couple hundred meters. And you can unpack it and set it up in a day and drill, and then you can pack it up into a sled and move it and drill at another site. And it can go in and out of a fixed-wing plane. So the cores after they're drilled go into ice core boxes, and they get put on a cold deck flight, meaning that they stay on a plane that is well below freezing, that sometimes you have to fly on as well. So they stay frozen back to a U.S. station, in this case McMurdo, where they get on a frozen container vessel. So they stay frozen on a ship all the way from Antarctica to California, and then they get on a freezer truck, and they cross the United States on this freezer truck that drops core off at institutions across the country that had drilled that year. And so we're in Woods Hole, Mass, and we're the last stop. And once the core gets here, it goes into a big walk-in freezer where I can saw the cores and subsample them and melt them to do different analyses. With my particular work, because I'm in the field a lot, something that is sort of difficult is that I love being in the field, but no matter how much I think I'll, write a paper or even read a lot of papers in the field, you're really just working, and it's a month or longer than a month. So every year it's kind of this switch of mode between being out in the field and doing sort of mechanical things and not really having much time for, in a way, the science side of it, and then coming back and jumping back into what's going on. So sometimes that's a little bit difficult, going back and forth. I know that I absolutely love working at the poles, and the thought of not going back this year, which is probably the case, is just killing me. So I definitely want to do this kind of research indefinitely, and I do love to teach, so I would guess that I would end up in academia. I have loved my time in the joint program, and I think I'm really lucky, and it's what I need to be both here part of the time and in the field doing all this field work. I love both sides of it, and I probably couldn't do one without the other.